So first things first is Captain America's time. So it's just Civil 3D alone, the traditional way of constructing roads and intersections. So if I jump to Civil 3D, we can actually go start off just to indicate one more time. There are already existing surface, which is called NGL, as well as I've got outlines for the polyline. So we're going to design these 2 roads, and there are additional 4 roads, which you can also go and design a bit later on. Now, like I mentioned, the assemblies have already been created. The assemblies for the roads are already set up, as well as for the intersection design, as well as the bow mouth design. So all of these are already set up and ready to go. So my main objective is to design these 2 roads and the intersection. So what we're going to do is I'm going to go time myself and quickly do all of these steps. Now, I'm not going to mention each and every step I'm doing, but I am going to call this Captain America because this is his drawing file. So like I mentioned, I'm going to go into a little bit of technical details right now, but you'll find the benefit as soon as I go. So without delay, let's start this thing. So quickly, if I want to go create any type of alignment from an existing object, I can say alignment from an object. So if I go select, it's going to ask me to select for which direction I want, and it indicates the direction. So I can give this thing a proper name, specify the site, as well as defining the label set. So I'm going to change this to major above center line. The design criteria, because all of our roads are according to standard, it needs to be designed according to Sunroll. I'm going to use that as an example, and I'm going to say use design check sets. So I simply say okay and transform the polyline to an actual alignment. Now the critical next part is to do design is the profile design. So if I go to create profile from surface and I add it to my system, and I can simply say draw in profile view. For those who don't know, profile is a fancy word for vertical alignment in Civil 3D. So I need to set up my bands and my station range to set up my long section, or in this case, as we call it, a profile view. So I set up the bands and I say create profile view. So as soon as I do that, I can place the profile wheel somewhere here in the space. And now I'm ready to do the next design. The next design is the profile design itself. So how I'm designing it as a civil engineer, I just set up one setting. I don't want labels on these things, as well as it also has its design criteria, which is normally our K values that we need to specify in a long section. So I can say use design check, and there we go. So I can just quickly model up and design this road. So just for time consuming purposes, I'm not going to design it 100%, but I'm going to at least design it very closely to accurate. So let's say, for example, I'm going to place it somewhere over here and just snap to the end. There we go. Then what you can do is you can actually go and add free vertical curves. So I like to use this free vertical Palapora PVI base because it allows you to give a few settings. So we'll specify the radius as 100. And there we go. So as soon as I do that, that's now sufficient enough. You can still add more PVIs if you want to, but like I said, this is a time constraint. I am trying just to get as much as possibly done to design 2 roads and the intersection. So as soon as I do that, very critical, I need to design my super elevation because I do have bends around it. So I can go and specify, create super elevation now. And I can go specify what type of system. Now I want an undivided planar, as well as which side is my high side. Left edge will be fine. And then I can go and say next and specify the normal lane width. So in this case, I'm going to specify the width as 3.7. The outside edge shoulders, I can go and specify, as well as we have design criteria for the super elevation design as well. I'm just confirming I'm using Devotex Sunroll standard. So as soon as I do that, I can say automatically resolve overlaps if there's overlaps in my super elevation. And there, ladies and gentlemen, it's done. So we've designed the alignment, I designed the profile and the super elevation. Now the next step is I need to basically go and combine everything else. You can also see in the long section, it actually adds that super elevation details. So the critical stage now is I need to go and put this together. So that's what we call create a corridor. So if I go to my tab, corridor, I can go and create a specific corridor and specify the profile design. My assembly, I'm going to use as road, and my target surface needs to be NGL. Then I can say set off the baseline parameters, and there we go. So that's creating just one road on its own, but there are some few elements that's missing inside of my long section. As you can see, the values and the levels are not correct because I need to extract those data. And those data that I acquire is called ETWs. It stands for edge of tileway. It will pick up the levels on each side of the road. Now, in Civil 3D, the old-fashioned way, we need to do this by hand. So I am literally going to say create profile from a corridor, and I'm going to call this road 1 ETW to the left. The style is to the left, and I need to do exactly the same thing for the right-hand side. So as soon as I do that, I can simply go and create it, and I can say road 1 ETW to the right, and I can just change the style to ETW to the right and simply say OK. So as soon as I do that, it creates the two additional profiles, and as you can see in my long section, they have appeared. Now, one thing I need to set up manually in the old-fashioned way is I need to go to my profile view settings so I can correspond the correct data inside of my bands, or in our case, on our vertical long section. So this is a bit of a tedious process, and we need to do this manually. So what Devotech IDAs actually have done, they've made it very nice with their styles, and if you're even a beginner, it's very easy to follow. So in the styles, in the beginning styles, it tells you which profile goes where. So I'm just going to change quickly these things. That needs to be VA. This needs to be road ETW to the left. VA, ETW to the right. Yet again, VA. Oh, sorry, that needs to be NGL. Yes, that's correct. And I can simply say apply and OK. So there we have created all of the correct data inside of the long section, and now it corresponds to my perfect design. Then something to mention, what we do require a bit later on is, as you can see, the levels and the super elevation. So another way of displaying this abilities is by creating a topo surface for my road. Now, the old-fashioned way we need to do this, we need to simply go select the corridor, and inside of the corridor, I need to go to my corridor properties and manually add these surfaces. So if I go say add the surfaces and I rename it, so I'm going to call this, let's say, road 1 top. So it picks up the specific code. I can give this thing a specific style as well. So let's make it contours colored 0.2 and 0.4 increments. And I need to go and add to specify the code and specify top links. Then for the boundaries, so that the surface does not extend outside of my boundary, I set up that details and say apply and OK. As soon as I do that, it actually builds the entire road. Now, in this stage, I am happy with it, but now I need to do exactly the same thing for row 2. So you can see where this comes in a bit tedious. So let's just quickly create from objects again, because this is a challenge, ladies and gentlemen. Just bear with me. We are going to do this, but you'll find the benefits afterwards. So if I just go quickly set up the sun roll again and say, OK. Oh, my fudge. You might have noticed this could happen into your industry. When under time and compression, you make little mistakes. So I selected the wrong option. Let me just do that again and say reverse this and say from an object. This does happen sometimes, and this is why I want to put emphasis on it when using the other version, which I was quickly going to discuss with Civil 3D and Devotech IDAs. So just quickly just do this again. Devotech roadway design standards, use a design check, and simply say OK. So as soon as I do that, we've got this alignment again. And I need to go and design the rest of the road. So if I go to profile, yet again, create surface profile, and I go specify road. So there's a road 2 and a road 2-1. So when you do a mistake like this, this can cause even more confusion. So that's why always be precaution when selecting your elements and creating them. But there's a big benefit. There are much easier ways than this to be done to reduce this amount of errors. So I'm just going to go run through all of the systems again and say create the profile view. Then I'm going to place the profile view somewhere close, and there we go. So yet again, the second step is I need to go and yet again, the second mistake, selecting the wrong icon, profile creation tools, and now I'm going to do the design. So, like I mentioned, I did this deliberately because sometimes it does happen in our industry. Clients do want stuff faster, and as engineers, we are pressured for time, so making mistakes is a very critical element for us. And I'm going to show you a bit later on how Devotech IDAS assist us in reducing these amount of errors. So I'm just going to quickly go and design this road. I'm going to keep it very simple. Let's place it very close to the NGL. I'm going to place it somewhere, let's say very close to this NGL, somewhere over there. Or let's move it a little bit up, a little bit. There we go. And I can go and adjust it. And I'm going to just snap to the end, and Bob's your uncle. There we go. So I just want to go and confirm. That looks a little bit too steep. Let's just move it down a little bit. There we go. That looks much better. Wonderful. So I've designed the alignment, the profile, and now I need to go and define the super elevation design for this. So yet again, to do the super elevation design, you simply select the alignment, and I go to super elevation design, and I can say calculate and edit super elevation. So as soon as I do that, I'm going to go undefined planner again, and you actually have more capabilities. You can choose any type, really. Depends on what you're designing. So I'm going to just go quickly fly through this. Next, yet again, 3.7. Next. I don't want outside shoulders, so I'm going to switch that off and say next. And I am using the right standard, either sun rolls, and I can simply say automatically resolve overlap. And I can simply say finished. So as soon as we do that, it designs the entire super elevation. And now I can actually go move on to the next stage. Yet again, I can go and create the corridor. So corridor selection, there we go. It actually creates a row 2. And let's go specify the VA as well as the assembly is still road. And the target surface is NGL. I'm not going to set the baseline region parameters this time, so I simply say OK. And Bob's your uncle, there we go. So 2 roads took at least about 10.59 minutes to do. So, and I still need to fix up this road segment inside of the long section. So it's still not 100% complete. So let's quickly do this together for the last time, ladies and gentlemen. I'm going to just add the ETWs because this is all about performance and accuracy. So I can give this thing quickly a name. I'm going to call this road to ETW left. And I can go set up the rest. This is actually supposed to be left, ETW to left. There we go. And simply say OK. Then I need to do exactly the same thing for the right hand side quickly. Let's do that. Specify ETW to the right. Give it a naming convention, road to ETW to the right. And simply say OK. So as soon as I do that, it creates the 2 profiles. So if I zoom into the actual one, you can see the super elevation taking an effect on the profile. Something I need to mention is in Civil 3D, this ETWs are static. So if there is modifications being made into this file, they won't update. So if I change any type of my profile design, these will not update. So that's something to note, but this is in the past. There's a better way of doing it using some awesome tools inside of Devotech IDAS. So I'm just going to finish up this real quick. There we go. Change the last one to NGL and Bob's your uncle. Apply. And let's just check. Yeah, that's perfect. It's now having the right data. So I can simply say OK. And then one critical element I need to still add to the last road is just that topographic surface for the top road. Because if I'm designing the intersection design, I'm going to need that surface. So if I go to corridor properties and for the surfaces, I can say the last time for this for row 2, top. So I type in top and I can add the code quickly and say top links and boundaries and quickly add the corridor extend to outer boundary. So I simply say apply and OK. And there we go. Oops, I forgot to actually go and change this style. So it's now set to triangles. Now there's a faster way of actually changing a style. Instead of going to the properties tab, I can simply go and switch this out very quickly. So let's just change this to 0.2 and that looks sufficient. So technically it took me 13 minutes in total to design 2 roads successfully. Now what I want to do next is I want to start designing the actual intersection of this between these 2 main roads, and let's see how far we get. So very critical, what I want to do is maybe just switch off these 2 surfaces because they might cause some errors when I'm doing and graphic display when I'm doing the actual bowel mouth designs as well. So I'm just switching those 2 off, and now I can go and define this. Now the first step I need to do is I need to draw out my bowel mouth manually. So I'm going to go create a new alignment, and I'm going to call this bowel mouth to the left because I need to tie in the one road to the other, and I'm going to call the type as a curb return. For those who don't know, a curb return is a fancy word for bowel mouth, and as well as the curb return, I can go specify the style, and I don't want any labels, and we're not going to do any design criteria. Now this is a bit tedious. You need to do this for all of your intersection design when you do this manually. But never fear, Jacques is near, and Devotech Itis is around the corner, and they will show you the way, and we will look into that a bit later. So I need to go snap to that ETW just to connect to them, because they need to be exactly on that same spot, because that's where it's going to pick up that levels. So as you can see, I can quickly go and snap to the points, ETWs. The reason why we need to do this is because our bowel mouths are controlled by radiuses. So this is a nice function of how defining specific radiuses. So if I go and select the alignment and select the second choice and specify less than 180, because this is an intersection design and not an off-ramp design. So I need to specify the radius for my bowel mouth depending on what type of scenario you've got. We've got urban development in this stage, so I'm going to say 10 meter radius. Now I need to do this exactly the same for the other side. So if I do go and say alignment creation tools, and let's just quickly just do this alignment and say bowel mouth to the right. And yet again, this one it actually remembers the settings, so which is a bit time saver. And then we need to manually go and connect these elements. So I'm just going to select this option and just quickly snap. As you can see, yet again, I made another mistake, the snapping problem. So this can also occur, so it reduces the amount of work ethic you're doing in your company. But like I said, there are many ways that we can actually go and do these things faster. It's even scary at some point, but we will look into that a bit later. So as soon as I move this to the right position, so basically so far I've made 3 mistakes in this entire webinar. And like I said, this happens in real life. Nothing is perfect, but we always try to achieve something spectacular. So I'm going to go say alignment quickly again and specify this radius as 10 meters. So there we go. Those 2 are now nicely defined. And now the critical element is I need to link these 2 roads in profile view. So what I need to do is I need to go project road 1's top of surface so I can actually tie into that exact road. So road 1 is my main road, and the secondary, or road 2 in this case, is my secondary road design. So if I want to go and add just an additional surface, and I can say quickly draw in both, just say okay, there we go, and it adds that surface. So as soon as I do that, you see that's the representation of road 1. Now what I need to do is I need to make sure I tie into this road directly. So let me just make sure I've got the correct snaps on. So let's go to snaps, and let's just say switch off nearest node. Midpoint will actually work. There we go. And I can snap to that exact point. So what I'm basically doing is I'm tying the 2 rows to one another. So we don't have that the one road is higher than the other. That's the main critical stage. And then I want to just follow this line because it needs to tie in directly all the way to this ETW to the side. So I'm just going to insert the new PVI, and I'm going to add it to the new PVI. Yet again, the snaps is not correct setup. So let me just quickly fix this. And let me just switch on to the right snap. So let's go quickly to snaps, and let's say endpoint, and I'm going to switch off the midpoint, and there we go. So it's always the little stuff that makes the biggest difference in life, and those are one of them. So as soon as I do that, I actually changed, and as you might have noticed, if I rebuild the corridor because it's outdated, it needs to update those levels. Now, like I mentioned, the ETWs does not update in the old Civil 3D. As you can see, it actually still left behind. So you need to do this manually again over and over and over, which is very time consuming, especially if you've got a lot of projects. So you can think how much time it actually will save you when I show you the automated. So after I set up those elements, I can move on to actually defining these bowel mouth designs. So one thing I need to do is I need to also design the bowel mouth profile. So I connect road 1 to road 2. So I'm going to select road 1 to top surface, road 2 top surface, and I go define the style as to be top surface. So I can see these levels in profile view because the bowel mouth needs to go around itself and actually connect so that the water can actually drainage out of my intersection. Now, yet again, I need to go set up the create profile views. And I can say curve return and say next. So it has its own style. And I'm going to just quickly run through all of these settings. You just want to check. Yeah, that's okay. And we don't have a specific bands because normally these profile views you don't show to clients. This is just for you as an engineer. So I can simply say next. After this, there's no bands. And I don't have any hatching. So as soon as I do that, I'm just going to quickly do one, ladies and gentlemen. I know you guys are getting the feel for this. So what I'm going to do is I need just to link those two quickly together, and then we can build half of the intersection. So as soon as I do that, I can simply go to profile creation tools again, and I'm going to quickly link these two levels, because if you remember, in the intersection design, the water needs to run out of the intersection around the bowel mouth, and it saves a lot of time for your contractors and less frustration to do these bowel mouth more or builds inside in the real life. I'm talking about of experience. I've also have done this, and there are some designs I had to go and literally tweak some of the elements, and it was very frustrating. But with this workflow, it works very nicely. So as soon as I define that profile designs, I'm already set up to go and do this actual design. Now, the one thing is inside of intersection, one part of the road 1 is still having a curb and daylight function. So what I need to do is I literally need to go and split this segment, because if you can remember, half of the intersection are actually just road, not paving. So we just split the corridor and put in a new segment. So I snap to these points where the end of curve for the bowel mouths are, and the one for the beginning. Now this one did not snap. Let me just go say split region again and specify that position. As soon as I do that, it has this part, and I can go swap out that assembly. So I can say road intersection on the left and simply say okay, and apply, and okay. So it swaps out that part, and I'm only left now with this little gap inside, and that's exactly what I want. Now there's some little tactics about this, because before we set in the bowel mouth, I need to go and specify targets. So just to make my life a bit easier, I'm not going to go too much in depth. But what I need to do is I need to create a feature line target directly. So I'm going to go select the feature line target, and I'm going to target that ETW. They are very important, especially when I'm going to put up targets inside of my bowel mouth. So I'm just going to quickly run through this, and you will see where it comes in a bit later. So remember, we need to do all of this manually, ladies and gentlemen, and this is what takes the most time. But that's where the benefit for today is, because I want to show you the other way we can do it for previously. So I needed to go and actually go and define this corridor and push it back. And now we're all set up to start finally doing the bowel mouth. So ladies and gentlemen, we're almost done. I'm just going to go add one, because I get the feeling you guys understand what I'm trying to send out today. And I'm going to quickly add this baseline, which is the bowel mouth and its design. And there we go, profile. And I need to add a new region, because that's an entire alignment, and I only use a certain part of the bowel mouth. So I can go define the assembly, which is the bowel mouth on the left, and I can simply say, okay. So as soon as I do that, it adds the region, and I can go specify where's the starting station. The starting station is somewhere over here for the beginning, and the end for the other side. So then the next thing, I need to go set up frequencies, because frequencies control the amount of smoothness in your surface. So I'm going to change all of these to 1, because it's a bowel mouth. So let's just go add a log offset target. And you can even be more specific. You can add specific additional stations if you want even more accurate results or additional frequencies. So I'm going to just do 1 I like to have this one in because it reduces amount of errors inside of my intersection. So I'm going to just add one just to show you that you can actually add more frequencies for those who might have not known. So I can simply do that and simply say, okay. And I can set up the target to surface, and the target surface for my daylight is going to be NGL. Now the width target, I need to select for that feature line so it extends to that point. So I'm going to say auto corridor feature line, which I've generated, and so name the feature line. Then what I need to do is I need to set up a second target, which is actually the alignment. So the alignment is going to be for row 2, and I can simply go and add that part and simply say okay. And then finally, for the slope and elevation targets, I need to go define this element. So I'm going to select auto corridor feature line. Yet again, the profile I also need to set as a target. Oops, wrong one. Let's say row 2. There we go. And I'm going to go scroll down to the VA so it snaps to the center line levels. And ladies and gentlemen, we're finally done. I can simply say apply and okay. And there's one half of the intersection design completed. So if I do go select these 2 corridors, I'm not going to waste too much time on creating the other one. We are limited, pressured for time. But as you can see, it literally takes me about 25 minutes to actually do the design. So if you want to, you can actually go and add 5 more minutes to this clock to do the other half. But I'm feeling you guys get the idea. And like I mentioned, this is the old-fashioned way that we used to do these things inside of Civil 3D. So you might be wondering, is there a different type of method of doing this? There is. So just want to show yet again, if you do want to go create it, you can still go and add a new baseline and then you specify the alignments. But I still need to go to design this profile view, which I did not do. So like I mentioned, it will add to the clock at least more 5 minutes to do this other half of the intersection. So I'm going to stop this, and our total was 25.4, 8.95 minutes. Whew. So what does Iron Man has to say about this? Well, he says, well done, old man, I suppose.